All right. In this problem, focusing in on the challenge, which is down here in the square root part. Um, okay, I'm going to think about, I know I have to let x equal something. So when I factor out, I have a 1 there. So I know I need a 3. And again, I don't know what trig function to use first. So I go back to my cosine squared theta plus sine squared theta equals 1. Okay. And now in this case, I notice that I have a sum here and I need a subtraction there. Okay, so what that usually indicates for me is that I need to maybe move this this term over and see if that will simplify. Okay, so I'm going to subtract the cos or the sine squared from both sides, and I get 1 minus sine squared theta. Okay, and then this looks like this if I have a 9 I can factor out, which is why I have a 3 here. Okay, so this form then really determines which trig substitution you need to make. So this looks like it's going to be a sine substitution. So I'm going to let x equal 3 sine of theta, which means then my dx is going to be equal to 3 cosine theta d theta. Okay, all right. Let's go ahead and plug everything in. And remember, after we substitute everything in, if this looks more difficult than what we started with, then we probably made the wrong choice. So let's go ahead and plug everything in and see what we get. Okay, so x is equal to 3 sine theta. So this is going to be 3 sine theta squared, replacing this x squared here. dx is this mess here. So 3 cosine theta d theta. So that's the dx part. And then downstairs, I have a square root of 9 minus 3 sine theta squared. Okay. Simplifying everything out in the next part here. This is going to give me 9 sine squared theta cosine, oh, sorry, 3 cosine theta d theta. And I kind of keeping everything separate a little bit. So, for example, I'm not multiplying 9 times 3 because I'm expecting some things to cancel out. So I'm going to factor out the 9 in one swoop. So 3 squared gives me 9, and then they both have a 9 in common. I'm going to factor that out, and that leaves me with 3, 1 minus sine squared theta. And then I got my d theta up there. Okay. Okay, and so now, just like we saw up above, this is going to be equal to my, should be cosine squared. That's equal to cosine squared theta. And so I have 9 cosine squared theta under a square root. When I take the square root of these, this is going to give me a 3 cosine theta. Okay. So it's going to cancel out nicely with that part of the d theta or the dx from here. So it's going to cancel nicely with that, which I didn't know what part was going to cancel, but I knew something nice should happen if we made our choice for our substitution um, cleverly. Okay. So I'll go ahead and write the square root canceling out here. So I'm not going to, but that'll give me a 3 cosine theta downstairs, which is what will reduce then out of the denominator there. And now I'm just left with the integral of 9 sine squared theta d theta. Okay. And we learned last section that when you have an even power of sine or an even power of cosine, you want to use the power reduction formula because there's no other odd powers here. So I'm going to factor out the common factor of 9 here, and then the power reduction for sine squared is 1 minus cosine of 2 theta, all divided by 2 d theta. And this one half here, I'll factor out in front as well. So I'm really integrating two separate integrals. I have the integral of d theta, where I have the 1/2. Oh, sorry, that should be 9/2. Sorry. The 1/2 is here and it's being multiplied by 9, so it's 9/2. So the d theta comes from this part minus the integral of cosine of 2 theta d theta. It's like I'm running out of real estate there. Okay. All right. So the first integral is going to be sort of really straightforward. That is just going to be theta. The integral of d theta, that is theta. Okay. here for the u sub part, I have or for the cosine 2 theta, I'm going to let u equal 2 theta. Then du is going to give me a 2 d theta, which means I need a half here. Okay. So I'm going to get a minus 1/2 coming from then the integral of cosine of u du, the integral of cosine is a negative sign. Uh, sorry, I said that backwards. The integral of cosine is sine. So this is going to become the sine of u, but u was 2 theta. So this is going to give me a 2 theta here, plus some constant. Okay. All right. So now we have our integrand, but our original integral were in terms of x's, and our results are in terms of thetas. So let's use the triangle and try to put things back into perspective. So we made the substitution x equals 3 sine. So sine is equal to opposite over hypotenuse, which means the adjacent leg is going to be equal to 3 squared, the hypotenuse, minus x squared, using the Pythagorean theorem. Okay? All right. For the sine, or for the theta part, that's actually just going to be found directly from our original substitution. So we're just going to solve for sine, or for theta individual here. Okay, so this part is going to be equal to the arc sine, or sine inverse of x over 3. Okay, this part, we have a double angle here, and this is in terms of our original angle. So we're going to have to first recognize that sine of 2 theta is equal to 2 cosine theta sine theta. So that's a trig identity that we need to know. The nice part about that is that the 2 and the 1/2 will cancel out. And so we just need to know the sine theta and the cosine theta. Well, the sine theta, we already know, that's x over 3. And the cosine theta is going to be this term divided by the hypotenuse. Okay? All right. So putting all of that fun together, we're going to have 9 over 2. This is going to be arc sine of x over 3. Okay, it's the first part. Minus the 2 and the 1/2 will cancel, so we don't have to worry about those. The sine of theta, we already know, is x over 3, so let's write that here. Okay, that's the sine of theta, and then the cosine of theta is going to be this part divided by that. Okay, so it'll be the square root of 9 minus x squared, all divided by 3, the hypotenuse. Okay, and then plus c. There's a bunch of constants that we can, so we can just rename this, or just write it there. If I distribute the 9/2 through, you'll notice that the 3 times 3 here is going to cancel with the 9 upstairs there. So I don't know if it's simpler or not, but I'm going to write this as 1/2 arc sine of x over 3 minus the 9 from 3 times 3 is going to cancel with this 9, so it's going to be minus 1/2. I have x times the square root of 9 minus x squared plus a constant. And so there is our final result. Okay, I hope that was helpful, and I'll see you in the next video.